there's a balance, an equilibrium between what's in the air and what's in the ocean. So if we have more of carbon dioxide in the air, which is coming from burning coal and oil and gas and making cement, which surprises people, also from burning rainforests and forest fires. So more carbon dioxide in the atmosphere has gone up about 40%. That ends up about 25% of it, 30% goes into the ocean. So we now have more carbon dioxide in the ocean, sort of like carbonated drinks. And there's some chemistry that goes on, and that's where it gets, it's not overly complicated, but when carbon dioxide, CO2, interacts with water, which is H2O, we actually began to break those down and form a weak acid called carbonic acid, H2CO3. Just the way those elements interact. And that often breaks down quickly into what we call bicarbonate, which is a H plus a carbonate, and another H, a free hydrogen, and that's what makes pH. That's what makes it acidic. And those relationships can kind of go back and forth. So basically the carbon dioxide begins to make some changes with water that produce these free hydrogens, and that's what gives the H and pH. So we're not lemon juice or battery acid, but when you're immersed in water that's a little more acidic and you have to make a shell out of it, the most vulnerable life stages for any organism is their egg or their larvae. I mean, think of a human baby versus you or I. You know, they're totally dependent. Other animals, you know, a little deer out here in the forest, boy, within an hour it's walking around. But humans aren't that way. So when we're looking at sensitivity to pollutants and things like acidic water, we're looking at the larvae. So like oysters, we have these hatcheries along the Washington coast. They spawn out these little baby oysters, and they have a planktonic larvae. So in the natural world, they would get into the water, they'd move around, coral do the same thing, and when it finds something hard, it'll attach and start to make a shell. But what they're finding is the water coming up from the bottom that they were bringing into these hatcheries was bottom water that was more acidic, and all these larvae were dying. Because what they can do, interestingly, with an oyster hatchery is you can actually put these little larvae on wet paper towels and ship them around the world to start a new oyster colony. Until they get on something hard, they won't metamorphose into one with a shell. So that's some of the impacts we're seeing that, again, you wouldn't notice unless, in fact, the hatcheries are trying to determine what time of day they take on the water, or this one biggest hatchery is going to Hawaii to try to get away from the more acidic water. So the chemistry is sort of subtle, but, you know, I spent 3.5 months a couple of years ago on a ship. I was teaching on a program called Semester at Sea, which is an interesting, being around the world for 3.5 months with 550 college students on a 600-foot ship. Not very many private spaces, but we went from Ensenada to Japan, and it was 18 days, and you look around, you're surrounded by water. There's nothing out there, absolutely nothing. The water averages 12,000 feet deep. There's 330 million cubic miles of water in the ocean, and to think that we have actually changed the pH of the ocean by about 30% is really scary. It's not just the water in this little pond or my swimming pool or the hot tub. And because organisms, when we're in the air, as we live, we can handle a pretty big range in temperature, and not, I mean, we can be from 65 to 85 and feel pretty comfortable.
Sure.
And we can survive at 115 and freezing, but not for a long time. But when you're immersed in water, like a marine animal is, like, it's sort of like, think about a hot tub. As you change the water from about, like, just a degree or two, from 103 to 105, you feel that. You're completely immersed in it. Or the showers, whoa, it's too hot. But that's not like the air. That water is pressing in on you all the time. So those fish and shellfish are not affected by water temperature, and which is why we have some during El Nino years, we get tuna and albacore moving north. We have these Humboldt squid that are moving north. Species distribution starts to change as the water temperature just undergoes a few degrees temperature change. And we don't know if everything's related to that, but the oceans are just a lot more sensitive because those organisms are bathed in that all the time.